So this section is all about hyperbolas. And I drew a picture of our inverted cone where all of our conic sections come from. And if I were to take a plane and slice a cone that in a way that it goes through two of the cones, the shape that would end up would be basically it would be two parabolas. And one parabola would come from this cone on top, and another parabola would come from that cone on the bottom. And the two parabolas together make up a hyperbola. And the points of interest that we're concerned with is first, the center, we're going to work with H and K as our center. For today, we're going to only work with center at the origin. The foci are the C values, just like when we were working with ellipses. We had A values and B values, which were our vertice values, and our C value is the foci value, and the same thing will happen here. And the C value tells us the distance from the center. For the foci. When we're working with hyperbolas, technically, if we look at this picture here, we're working with two vertices. Although these are the vertices that are on our graph, it's helpful to have the other vertices on the, I'm going to call it the non-important side of the graph, because that helps us determine how wide or how skinny our branches of our hyperbola are going to be. So there are two vertices on the hyperbola on the graph. And then the other two vertices that we would consider maybe on the minor axis or on the non-important axis, those necessarily don't have to be labeled, but placing them on the graph is actually kind of important. The transverse axes is where everything happens. The center, the vertices, the foci, all of this lie on the transverse axes. Okay, and then something else, and I don't see these in any of the pictures, so I actually drew them in here. We have these asymptotes, and these are called slant asymptotes because they are diagonals. And these are just guiding lines that help us show where each of these branches of the hyperbola are going to approach. They're not going to intersect here, but these are just kind of some guiding lines here that are going to help us. So these are diagonals. That our graph doesn't cross. Okay, so those are asymptotes. All right, so let's look at an equation of a hyperbola. The center is at 0, 0, so center at the origin. And here it says the transverse axis is along the x-axis. All right, so the transverse axis is where we have our foci, our vertices, and our center. It's along one axis. If the transverse axis is the x-axis, then the x term must go first. So you're going to have x squared over an a squared. So x must go first. Okay. If the y value is going first, and we'll look at some equations that have that, that means our transverse axis is up and down. So we would have a center, we would have vertices, and we would have foci on a vertical axis. So this is determining if x squared comes first or if y squared comes first. This is determining which way our transverse axis is going to be. And then we have some equations here of our diagonals. And when we get to drawing those on a graph, I'm going to explain this a little bit more in detail. So if we look at this first example, it says to find an equation of a hyperbola with the center at the origin. So here's my center. It has one focus at 3, 0 and one vertex at -2, 0. So if I were to graph that, always do the graphing. So my center is at the origin. My focus is at 3, 0. And my vertex is at -2, 0. Okay, so when I had a focus at 3, 0, just like with the ellipse, I drew another focus just automatically on the opposite side with the same distance away from the center. And if a vertex is at -2, 0, I'm going to do that as well. Reflect that over the center, same distance, and I have a vertex here. So I have my transverse axis with everything on it, 2 foci, 2 vertices, and a center. So this tells me, because x is the transverse axis, I'm going to have x squared over a squared minus y squared over b squared equals 1. Okay, just very similar to the equation of the ellipse, except for the ellipse, the equation has these terms added together. With a hyperbola, these are subtracted from each other. All right, so I know that because my distance from the vertex, this is going to be my a value, my a is 2, and my distance from the center to the foci, my c value is 3. To find my guiding vertex values, I'm going to use the equation b squared equals c squared minus a squared. Or if I solve this equation, I'm going to have c squared equals b squared plus a squared equals c squared, or a squared plus b squared equals c squared. So if I plug these values in, I should be able to find out what our b squared value is. That's going to help me in the equation. So here I have a squared is 2, a is 2, so a squared is 4, plus b squared equals c squared, which is 9. So I know this value right here has to be 5. And our b value is going to be the square root of 5, which is square root of 5, which is about 2.4-ish. So that means along this axis right here, I'm going to go up 2.4 and down 2.4. And these are my vertices that really are not part of the graph, but they are going to help us here in a second. Completing the equation, which is what they ask us to do first, I'm going to have x squared over a squared, which is 4, minus y squared over b squared, which is 5, and that equals 1. So here's my equation. Now to complete my graph, the easiest way to get your slant asymptotes is to draw a box around the four vertices, the two that are on the transverse axes, and then the other two that are not really so important in terms of the graph, but they do help us to draw in our slant asymptotes. So if I were to draw in a box around all of the vertices, the diagonals are going to be, let's do this. The diagonals are going to be my slant asymptotes. And often I will be asked to write the equation of these. So this is going to be y equals. Now I'm going through the origin, so I really need to determine my slope. And I'm going to go up 2 1/4. So really this is the square root of 5 over 2. And this one would be, I'm sorry, this one is square root of 5 over 2. And this one is the same thing, but it's negative. Okay, so the equations are y equals square root of 5 over 2 times x. One line is positive, one line is negative. And then to complete the branches of the parabola, on the vertices, I'm going to draw this in, and it's going to approach my asymptote, but not cross it. So it looks like that. So here's another one in example 2. We're going to analyze the hyperbola equation. So this is a squared is 16. So b squared is 4. So our a value is going to be 4. Our b value is going to be 2. Probably right away we should find the c value, because that's going to tell us where our foci are. So remember, c squared equals a squared plus b squared. A squared plus b squared is 20. So c squared equals 20, and c is the square root of 20, which would be approximately 4 times 4 is 16, 5 times 5 is 25. So this is approximately 4.5. And that's what we'll use when we graph. And because x squared comes first, my x is the transverse axis. Okay, so kind of like the major axes in the ellipse, it's kind of the important one. So that means everything that I'm going to put here is on the transverse axes. My center is at the origin. Okay. The next lesson we'll look at transformations where the center isn't at the origin. So I have the center at the origin. My a value along the transverse axes is 4. 1, 2, 3, 4. And that's a vertex. And I have one in the opposite direction. I have a foci at about 4.5 and negative 4.5. And then on my minor axes, I have these non-important vertices at positive and negative 2. So if I were to connect my vertices, make a box, so these are my vertices, and make a box around all of these. This is going to help us with the diagonals. That will help us guide the parts of our hyperbola. And these equations, remember I have y equals, and I'm going to look at the slope, up 2 over 4 up 2 over 4, or 1/2 times x. This one is negative because it's going down. This one is y equals 1/2 x. It's positive, it's going up. Okay, so from my vertex on each side of the rectangle, I'm going to draw in my branches of the hyperbola. And notice when we were working with the ellipse, when I had the enclosed circle or the enclosed oval, the foci were inside the enclosure, and in the hyperbola, our foci are farther away than the vertices. Okay, so the foci have to be on the outside of the pieces of the hyperbole. All right, so I think we have everything here. The center, my vertices, if I label them, are 4, 0 and -4, 0. My foci are going to be at, this is the square root of 20. I should keep the exact value here. So this would be 2 square root of 5, 0, and -2 square root of 5, 0. Okay, and I have my asymptote equations there, and it should be all set. Now, also, we're going to look today at equations where the transverse axis is along the y-axis. And again, the axes that the hyperbola will be on comes first. So y goes first. Okay, y squared over a squared. So these numbers, the a value goes along the y-axis, the b value goes along the x-axis. The equations for the asymptotes, the diagonal or the slant asymptotes, are pretty much the same. I don't want you to get so hung up on a over b, because over here this was b over a. This is just the slope of the line, and yes, it does come from the values of a and b in the equation, but depending on whether it is horizontal or a vertical transverse axis, these a and b values could be flipped. But just think of this as the slope of the line. Okay, and actually go to the center and count up and over to get that value. So looking at the next page, it says to analyze the equation. So first we need to put it in the right form, and we do need this to be a 1 at the end. So I need to divide all parts by 4. So this becomes y squared over 4 minus 4x squared over 4 equals 1. And actually, I should have canceled those, so I have x squared over 1. So I know my a value is 2, my b value is 1. And if I want to find how far away from the center the foci are, I need to have a c value. And remember, a squared plus b squared equals c squared on this one. So c squared would be 4 plus 1. So c is the square root of 5. All right, so if I graph, I have the center. My a value is going to go along the y-axis. Now that is the transverse axis, and that's the vertice here. My b value is the vertice along the non-transverse axes, so we're still going to write those. And my foci is the square root of 5, which is just a little bit more than the square root of 4. So that's going to be about 2.3-ish. So it is a little bit more than 2. So I'm going to have a foci just a little bit past my vertices on the positive and negative part of the axis. Okay, so if I make the box now, this is my vertices box that will help me to draw my asymptotes. And here are my slant asymptotes. And if I were to write the equation of this, this line is y equals negative because it's going down. My slope is up 2 over 1, so negative 2 times x. This one is y equals, and this one is positive 2 over 1 times x. They're the same slope, just one is positive, one is negative. All right, so analyzing, let's see, we've got the center at 0, 0. We've got the vertices on the transverse axis, so that would be over 0 up 2 and over 0 down 2, or negative 2. I have the foci, and that would be over 0 up the square root of 5 and over 0 down the square root of 5. All right, so we've analyzed this, and actually the last thing we can do is draw in from our vertice on the transverse axis. We're going to draw in the branches of the hyperbola, approaching the asymptotes but not touching. Example 4, find an equation of a hyperbola having a vertex at 0, 2. So as we look at this, let's graph it. Over 0 up 2, here's a vertex. And a foci at over 0, negative 3, so here's a foci. And a foci at 0, negative 3, and 0, positive 3. So here's the other one. And I have a center at the origin. I also have another vertice 2 units away from the origin. So this looks like my transverse axes. Now, because my transverse axis is on the y-axis, the y goes first. So I have y squared over a squared minus x squared over b squared equals 1. And from this, I know that my a value is 2. My b value I need to find out. And my c value is the distance from the center to the foci, and c is going to be 3. So if I use a squared plus b squared equals c squared, I'm going to have a squared is 4 plus b squared equals 3 squared is 9. So this would have to be 5. And my b value here is the square root of 5. Okay, so that's going to help me with my non-transverse vertices. So my b value is 5, or square root of 5. That's going to be about 2.3 we set up here. So this is about 2.3. So over 1, 2.3, 1, 2.3. Now let's draw the box through the vertices. And the diagonals. If I write the equation of the diagonals, this is going to be up 2 over to this vertice, which is square root of 5. And if I write that equation, let's do this, y equals, this is the up 2 over the square root of 5. I know it's not polite to leave the square root on the denominator, but I'm not going to rationalize the denominator for this. Okay, so the slope is 2 over the square root of 5 times x. This one would be negative 2 over the square root of 5 times x. And finally, from my vertice, drawing the curves towards the asymptotes. So here's the graph. Now we need to find the equation. So we're going to just put our a squared and b squared values in. So I'm going to have y squared over a is 2, so that a squared is 4, x squared over b squared was 5, and that equals 1. All right, so one more for today. We're analyzing this equation, and I'm going to divide by 36 to put it in the proper form. So this would be 9 over 36, so this would be x squared over 4 minus 4 goes into 36 9 times, y squared over 9 equals 1. This tells me that a is 2, b is 3, and my transverse axis is the x-axis. All right, so let's graph. I'm going to go over 2 to get my vertices. I'm going to go up 3 to kind of get those guiding vertice points here. I need to find my foci. So a squared plus b squared is c squared. So 4 plus 9 is 13. So c is the square root of 13, which is a little, it's between 2 and 3, so about 2.5. And this is going to go, here's center, here's vertices. It's going to go on the x-axis. 1, 2, 3, 2.5 is here. Here's 2.5. So now I can draw my box. Around my vertices, I can draw the diagonal slant asymptotes. I can write the equation. My equation is up to this point, which is 2.5, or no, what is that? My b value is 9. So this is up 3 over 2. So this is y equals 3 over 2 times x, up 3 over 2. So this is y equals negative 3 over 2 times x. We've got the equation. The center is at 0, 0. I didn't label my vertices, but I have one at negative 2, 0, and one at 2, 0. And it's my foci that are at the square root of 13. No. Yep, my foci are at the square root of 13, 0, and negative square root of 13, 0. Okay, so that's it for this first half of the hyperbola section.